Good morning, everybody. Welcome back to lecture number 5.5, where the point 5 is the missing part from previous lecture. For some reason, the camera went down. But because this example is important, I'm going to repeat it one more time. So, it is a 3-wire, Y-connected source to the load. So let's start drawing it. So I have here this is VAN, VBN, VCN, and this is the line, and the load is delta. So that's the load. Connected. So this is source, generation, transmission, distribution, or the load. So as he's telling me, it is Y-connected 3-phase, so I put the phase voltages. So I should start with VAN equals 120 angle 0 volts. Here I am taking the reference as the source, the phase source. In the slides, he is doing it for the load, the 2.8, the line, as he's taking it as a source. VBN is 120 angle minus 20 degrees, and VCN is 120 angle minus 240 degrees volts. So the first part is find the phase and line voltages at the load. Because the load is delta connected, phase voltage equal to line voltage at the load. So at the loads, it's going to be VAB equals VAN minus VBN. If you do it by the calculator, it will be 120 angle 0 minus 120 angle minus 120. So this will be, the answer will be 208 angle 30 degrees volts. If you look at the slides, he is using the VAB as the reference, 0 volts. Both are correct, but this is with respect to the load. Mine is the reference is with respect to source. Okay? Now, for the other two phases, so this is VAB. I always tell you to go back to this diagram. So this is VAB, this is VBC, this one is VCA. So this is A, B, C. And this current here is IAB. This current is IBC. This current is ICA. For the source, if the source was delta connected, you have to use the same notations here. For Y connection, it is much easier. Anyway, so what is VBN? What is VBC? It's going to be 208. 30 minus 120 is minus 90 degrees volts. What is VCA? Is 208 angle 30 minus 240 is minus 210 degrees volts. So we have answered the first part of this VIP, very important problem. The second part is find the phase and line currents. So let's start by having the phase currents. So phase currents for delta connected loads, phase currents, we have to find IAB, IBC, and ICA. Let me change the color. Or I think we have still. So what is IAB? It is VAB over ZA, which is going to be 208 angle 30 degrees divided by 12 angle 30. Keep in mind that every one of those loads is 12 angle 30. This one is 12 angle 30. This one is 12 angle 30. Do not add 120 degrees at the loads. هذه load. هذه ثابتة ما تتغير. Okay? It's very important. If you do the calculations, you will get the number 17.33 angle 0 degrees amps. 0 degrees with respect to the phase voltage, or in the slides it's minus 30 degrees with respect to the load phase voltage, which is line to line voltage because it's delta connected. IBC, I don't need to calculate it. It is 17.33 angle minus 20 degrees. This one is 17.33 angle minus 240 degrees. What is the line current? If you use the KCL, it is going to be equal to, using this equation, IAB minus ICA. So IA equal to IAB minus ICA. So this is going to be IAB minus ICA. If you do the math, you should end up getting the answer to be 30 degrees angle. Let me do it. So it is 17.33 angle 0 minus 17.33 angle ICA is minus 240. So this one should be 30 angle minus 30 degrees with respect to the source. So here it's minus 30 degree with respect to the load. Again, if you shift it by 30, everything else, this will be 0, this will be minus 30. Okay? Amps. So what is IB? Is 30 angle minus 30 minus 120 is going to be, I think it's going to be minus 30 minus 120 minus 150 amps, and IC is 30 angle minus 30, okay, 30 minus 30 minus 240 is minus 270 degrees amps. So both approaches are correct. You can use the slides approach, which is with respect to the load, or you can use my approach where the reference is taken with respect to the source phase voltage. Slides with respect to the load phase voltage, which is equal to the line-to-line voltage. Okay? So that is a very important example. Please study it, and if you have any question, let me know about it. The last example we did in today's lecture that was somehow carried. Again, I tried to investigate what is the reason why the lecture, why the video, and I think it's because of overheat or a failure in memory. The battery is fully charged. This is not the reason. So I'll try to avoid it, but next time, whoever sits here, please keep an eye on the camera with me, always, please. Otherwise, we have to do repetition. Now, in example 5, we have a source. We have load 1, load 2. This one is Y, this one is delta. The first step is we cannot mix Y and delta loads together because my goal is to find Z equivalent or Z thevenin. So the first step is to convert Z2 delta to Z2 Y by dividing it by 3. So this will be 4 plus J3. Clearly this is an inductive load. This will be 4 minus J3. This will be a resistor and a capacitor. The second step is to combine Z1 and Z2Y in parallel. That is the formula, 1 over Z1 plus 1 over Z2Y, Z2Y, equal to 1 over Z equivalent. If you do the math, you will get this would equal to 8/25. So Z equivalent is 25/8 ohm, which is a purely resistive load. The last step is to find IA, the line current. This is, even though this is a 3-wire configuration, and because it's a balanced system, we can say VAN over Z equivalent equal to IA. You can draw the single phase circuit, 120 angle 0. This is 25/8. Quick division, you will get 38.4 angle 0. Because it's a purely resistive load, it is in phase with the source phase voltage. So that's it what I have. I hope those two examples are clear. Again, be ready for the quiz next week. This is a very important example. This example is also important. Thank you so much. I'll see you on Thursday.